Welcome to Emila Online tutorial. Now in this tutorial today we'll be looking at the specific latent heat. Alright, previously I've been doing solving questions on specific heat capacity. Alright, if you're yet to watch this video, probably I'll be dropping it in the comment section. Okay, and here the question reads, now what amount of current would pass through a 10 ohms coil if it takes 21 seconds for the coil to just melt a lump of ice of mass 10 gram at 0 degrees Celsius if there are no heat losses. Alright, now let me give you a pictorial diagram of what this question is talking about. Now let us assume that this is the lump of ice. Let us say this is the ice. Okay. Now this coil, let's assume here, okay, now this is connected to a source. Okay. Alright, now this ice at 0 degrees, now with the heat from this coil, the ice absorbs this heat from this coil and melts to become water. So let us assume it's melted and probably become water. Okay, although flows down, okay, as usual. Now, but where am I driving at now is that ice. Let me just put this is this way. So originally from this ice to water, now still at 0 degree Celsius. Okay, now the ice at 0 degrees Celsius melt to becoming what? Water at 0 degree Celsius. Now this temperature constant is what we call the latent heat. Now a case whereby a substance changes state without a change in temperature. So this ice in its solid state changing to liquid, okay, at the same temperature, well, probably without a change in temperature, is what we call what? The latent heat. And that is what this question is actually referring or talking about. Alright, so but how then do we solve this? Now let us recall that latent heat is given as the heat, the specific latent heat is given as what? H equals what? The mass of the substance and the specific latent what? Heat. Okay, so this is the heat generated or absorbed when a particular change is occurred from the solid to what? Liquid at a constant what? Temperature. So now let us now marry that with this. Now the heat given or supplied by this coil equals to the same heat absorbed by the ice, okay, making it to change from the solid state of ice to the liquid state, okay, from still at 0 degree Celsius. So we can say that the heat supplied by the coil equals to the heat gained by what? The ice, okay, changing from ice to water. So now, and the electrical heat here will be given as what? I VT then equals to ml, where L here is the latent heat of what? Fusion of what? Ice. Okay, so writing out the parameters, we are given that the resistance of the coil is what? 10 ohms. Time is 21 seconds. What else are we given? The mass of water, sorry, the mass of ice equals 10 gram, and the temperature equals what? 0 degree temperature. What else are we needing here? And we are told that what amount of current. Okay, so we are looking for the current and the specific latent the latent heat of fusion rather is given as of ice is given as 336, okay, joules per gram. Okay, another thing we need to put in place? No. So, well, in this case here, we have IVT, okay, but we need to look at, okay, I is here. Now V is not here, rather it's R, but T is here. So let us recall that V equals what? IR according to Ohm's law. Okay, now making V the sort of formula here. Okay, making V. Okay, since V is equal to IR, so let us plug in let's plug in IR for V here. So you get to have I into what? IR, then T equals what? ML. So here we have I squared RT equals what? ML. So we can now plug in. And what exactly are we even looking for? The current. Okay, so divided multiplied by IRT, so our I squared equals what? ML all over what? RT. Okay, let us just solve this one first. Then the mass of the water is 10 gram. Now, since this is given in joule per gram, so we can just leave this as gram. Then times 336, which is the latent heat of fusion of ice. Then all over the resistance, which is 10, times the time, 21 seconds. Okay, so here we have, okay, let's just say the square root. Now we actually ignore the negatives. We are meant to have plus or minus here, but we just ignore the negative. So here we have that 3360 all over 210. And this will give us 3360 divided by 210. So here we have 16. So the square root of 16 is now what? 4.0 amperes. Okay, so here is the amount of current that we needed to pass through this coil to melt the lump of ice of mass 10 gram at 0 degree Celsius. Alright, if you love what I've just done, can you subscribe to my YouTube channel and ensure you click on the notification button to be notified of all my videos in physics and mathematics. And please don't fail to share this. Thank you and God bless you.